What's that? No. Fight your own war, Mr. President. I'm recording lab videos. So that should be us done with the first part of the Newton's rings experiment. So we should have measured the radius of curvature of the lens. We should have also got the refractive index of water from our third result, if we count the second one as a test of it. Hopefully you got decent results there. Hopefully you've done the statistical analysis. So I'm wanting you to determine the slope using the regression method discussed in the lab manual. So have a look at that. Ask me about it in the practical if you did not. However, what we're going to do next is the Fizeau Fringes experiment. So this is an additional part of the experiment if you've taken a long time to get to here, by which I mean it's the end of the second day and you're beginning to panic, like Link in Majora's Mask, and if you get that reference, here's a high five from me. But if you've plenty of time, then you can carry this out, and of course you can do it in your own time as well, and I'll still mark it, and I'll still help if you email me. We're going to use Fizeau's fringe method to determine the thickness of human hair. So I'm going to yank out some chunks of my hair. We're going to set it up and we're going to see how it goes. Not much has changed in terms of the geometry of the experiment. So the lamp's still here. I've had it on for actually about an hour longer than the manufacturer says is okay, so it's grown hotter than Zac Efron at the moment, and I shouldn't really be touching it, but still. That's still there. We've still got the traveling microscope in place. We've still got the glass slide at its roughly 45 degrees angle. But what we're going to put in instead are these two flat glass plates. You can see I've accidentally put my thumb right on the top of one of them, so I'm going to have to polish. But these plates are going to go in place. I'm going to put them like this, and then I'm going to take a hair and I'm going to just stretch it underneath this plate. So this will be elevated by the thickness of one of my hairs. Now my head hairs have grown quite short, so I'm going to use one of my coarser back hairs, but we'll see what we get. So hopefully we'll go okay this way. So again, I'm just going to give it a bit of a rub down. Just make sure, just holding it against the light, you want to check that there's nothing really too filthy on it. It's one of those things where if you're looking at the photos of the Newton's ring setup I've done, you'll see that it's actually bright in the center, which means that the lens is a little dirty. But in practice, you have to spend so long cleaning it to get rid of that, it's not worth it, and you can still get that bright spot just because the lens isn't perfectly formed. It can happen. All right, that's pretty good. So we're going to put that down there. Now this is hopefully still pretty aligned from the previous experiment in terms of the light source and where the glass slide is. So let's do this then. All right, come on. Fuck, I didn't even get one there. Fell on the floor. Let's try again. Come on. Oh, yes, son. I don't know if you can see that. Yeah? Oh, did I lose it? No. So, one good thing of coronavirus is my hair has grown excessively long. So I'm going to take the hair and just place it between the slides and pull it tight. Excellent. And when I look down through it, what I can see is very fine lines. I'm going to see if I can capture that on video. And you can see that I can't. If you saw it, you're probably meeting me more than halfway, so thanks for that. But the key thing is we're seeing these very fine lines, you know, that's the interference fringes coming from the separation of the two plates by the thickness of the hair. So there's an equation given in the lab manual for calculating it. But what I'm going to do now is put this back in place, and then just physically adjust it again, because I've changed the position. Yeah, again, until it's over the slides. Obviously we're now at a slightly different height, because the glass slides are thinner than the optical flat. But I've now got this set up so that I'm seeing nice clear fringes. So of course my next step is going to be putting the camera in place and taking pictures of the fringes and then pictures of the ruler at roughly the right height. And that's going to let you take the measurements that you need. But there we go, now I've captured a good number of fringes. Of course what you want to do, because you're a scientist so I shouldn't have to say that, but I'm still going to anyway, is average the distance between the fringes. So measure a bunch of fringes, divide that by that number, and that will give you the average fringe spacing. And for this one, putting the ruler in place is actually going to be more straightforward because the lens is quite thick. So we can't really, I can't just sit this on top of the optical flat, but the second glass plate that we have is actually quite slim. So what I can do is take the first glass plate away, put the ruler on top, and then it's roughly at the right value. That I can take the image and it's fine. So that should give us enough data to do the Fizeau fringes experiment.